38. Integrals. So integrals means we are doing the antiderivative, right? So opposite of derivatives. We're undoing the derivatives. Got it? Okay, so the idea here is integral of a sum. And really, it's a really short lesson because you guys already have the basic idea. When we do derivatives and there's different pieces added, we just do the derivative of each term, right? The idea of the integral is the same. They show it as the integral of f of x plus g of x dx. And the idea is that you do the integral separately. So you do the integral of f of x plus the integral of g of x. So again, it's just doing the integral of each individual term. On last night's homework, or? I don't know. I'd have to go back and look at it at this point. Okay, so example 1. Integrate 6s12, 6s to the 12th, plus 5s plus 3e to the, and that should say s, just because this problem is in terms of s, plus 4 ds. So, not that I expect you to do this necessarily, but what I just want to point out is that this rule up above basically says that I can separate this into multiple integrals. Honestly, when doing it, I wouldn't waste your time. I would just start integrate. But just to kind of make the point, the idea is that this is going to be the integral of 6s to the 12th ds plus the integral of 5s ds plus the integral of 3e to the s ds plus the integral of 4 ds. So just, again, I'm writing that out just to kind of show you that's what that rule up above is saying. That the integral of a bunch of terms added can be written as the integral of each piece. Now, if I do one other thing, and again, this is just kind of talking to you about rules. Do you remember constants? At one point in time, what did they show us about constants? Like 6. That can be pulled and put, well, no, it can be pulled and put outside here, out in front of the integral. Okay, so if it's a constant, because what's going to happen is when you take the integral, the constant's just going to multiply by it. Do you have to do that? No. Okay. Again, just trying to show proper notation and how this all connects. So the idea is, since this 6 is a constant, this could be rewritten as the idea of 6 times the integral of s to the 12th ds. Meaning the only part I'm really taking the integral of is the s to the 12th. On this next one, there's a constant of 5. So it's 5 times the integral of s ds. So meaning the only part I actually have to take the integral of is s. So plus 3 times the integral of e to the s ds. And on the last one, you can pull the 4 out. And it's 4 times the integral of ds. Am I saying you have to write it a lot like that when you do it homework? Okay. Huh? Not necessarily, honestly. However, if it helps you at this point, then yes. Okay. That's what I'll go with. Okay. Let's do some math here. How do we do the integral of s to the 12th? We're undoing our derivative here, right? Add 1 to the exponent, so it becomes s to the 13th. And you have to divide by 13. Now, what else do we have out front? 6. So, what is... Yes. However, I wrote it slightly different. But you and I, we did the same thing. So Wade said 6s to the 13th over 13, all over 13. I wrote mine as 6/13 s to the 13th. Either way works. And again, you need to realize that they're the same, right? Plus, okay, integral of s You add 1, it becomes s squared. So now it's s to the second. We also have to divide by the 2. So now it's going to be 5 halves s squared plus. Yep. Okay. Integral of e to the s. Yeah. The derivative of e to the s is e to the s. So the integral of e to the s is e to the s. So this is just going to be plus 3e to the s plus integral of ds. Okay. So for, what do we have to tack on with this for? S. Because think about it. If the term was 4s, you take the derivative, it's now 4. So the antiderivative is going back. So it's 4s. And then, don't forget, plus c. Yes, we broke it up into individual integrals. However, there is still just 1 plus c. Okay. I drew that problem out. Yes. You guys don't have to draw it out, but again, just trying to show you the pieces there. Questions?
Why did we have the s to the 4?
Because right here, where there is no variable, when it's just a constant and there's no variable, you can think of that as 4s to the 0. Like 4 is the same thing as 4s to the 0. So if you add 1, it's now s to the first. Divide by 1, it's still 4 though. And so that is 4s. Does that make sense?
Yes.
Or the other way is think about, okay, if I started with 4s and I take the derivative of 4s, I get 4. So then the antiderivative of 4 is 4s. Okay? I know, it's just trying to get it all straight in your brains at this point. Okay, ready for problem 2? Again, if you want to write it out, I'm going to write it out as all separate integrals and pull my constants out. Whether you do this part or not is up to you. So, if I break it up, it's the integral of 6 sine u. If I pull the 6 out front, it's 6 times the integral of sine u du plus 5u to the negative 5th. So if I pull the 5 out front, it's 5 times the integral of u to the negative 5th du